There you go. My name is Philippe Lafuclier. I'm a distinguished engineer for Secure and Defend, and this is the brainstorming session on the license compliance topic in the air-gapped environment. The idea here today is to see if we can find some new ideas to get license compliance more air-gapped compliant, which is not the case as of today. We have one engineer with us, Mo, who spent a significant amount of time already benchmarking and investigating, mostly in the current tool that we're using, License Finder. And there are some findings that are not in this talk yet. I will add that right after I finish this intro, where basically we have a few places where license compliance is not going to work in the air-gapped environments, mostly because in the way we are preparing the environment and also in the way that we are fetching the dependencies and matching or extracting the license information from the dependencies that we just installed, or the dependency tree that we just created. I created on Friday a very short deck to explain where we stand with that matter. I think, Mo, you've seen this deck on Friday already, if I remember well.
I read the issue. Is that the same as the slide deck?
It's exactly the same. It's
yeah.
just a visual representation of the issue. And so I will share my screen now with especially this slide. So it's nothing that has been documented so far or named or anything, but we need to start putting names on the different phases and different stages of what license compliance is doing, because we have this false feeling that license finding is just doing one thing, whereas under the hood, it actually does maybe 4 different steps, maybe more than that. I'm not so sure about that. That's the kind of things that we should discuss today. And of course, these names are completely work in progress. Feel free to use any other name, but we need to start somewhere. So with the sake of iteration in mind, let's start with analyze and then load, scan, match, and report, and see what we can do to improve that situation here. And so I guess we already have a comment. Olivier, you want to speak to your points?
Yes. Thinking back about this issue with private registry to download the dependencies, this issue actually applies to other categories like dependency scanning and SAST, because as soon as we need to build the project in some technologies, we need to download the dependencies. For example, I think for Java and some other like support languages in SAST, and everything that is supported bugs, you need to compile the project because you're analyzing the jars files. So you will need to download the dependencies unless the customer is customizing the job so that it provides the dependencies beforehand to the job itself. But I think we focused a lot on this for license compliance, but this is actually something that we will have to support for all other category features.
Yeah, and that's basically the idea behind creating these stages so that we can have a better overview of what we can share between the different categories that we have in Secure. There's obviously some overlap with dependency scanning, where we do exactly the same for at least the 2 first stages where we analyze and download. No, sorry, it's the first stage actually. I grouped that in one single stage.
Yeah, my point is that I agree with this when it comes to the logic to build the dependency tree. This is clearly focusing on license compliance and common with dependency scanning. But the ability to support that in an air-gapped environment is something stage-wide to me. Is that clear? I mean, the distinction between the two things. Is not?
I guess.
Okay, I'll try to rephrase that. So when you want to generate the dependency tree, you might need to download dependencies, but it's not always the case. You might just rely on some manifest file, which is available locally. But in case you need to download them, then the problem can be twofold. Are you able to reach to the registries or not? And the case when you're not capable because you're in a gap environment, this is a problem that is shared with the other categories. It's not just license management, license compliance, and dependency scanning. This is also true for SaaS, for example.
Yeah, okay, so I get that. And we obviously both agree on that. That's why I'm saying there is some overlap between license compliance and dependency scanning, and probably SaaS, as you said, where we have to download the dependencies. So to echo my comment on the issue, my latest comment, because I've seen what Mo did in the past weeks around, what do you call that, offline registries?
Yeah, I was trying to go about this problem a different way. Because like, okay, so if we like level set where we're currently at, the current assumption is that in order to determine the dependencies and the versions of those dependencies, and then also any software licenses associated with those dependencies, is we have to install packages. That is the current direction and the current assumption. Whether it's pulling it from public registries or from private registries, that's the baseline assumption. So I'm like, okay, well, if I'm in a truly air gap mode, what happens in a world where I can't connect outbound network connections? So I started with a different starting point just for fun as an experiment. I'm like, can I actually build an offline index of software licenses for every package / every package version? And if I could, what would that look like? How much disk space would it take? And why would I want to do that? So if I'm in a, like, you know, I'm going to say air gap because I think we're realizing it means different things to different people. But if I'm in a world where I can't make outbound connections, if I can provide you with an environment, in this case, a Docker image, where in that environment, it already knows of every software license associated with every public package, then at least when I do a scan of that project, I can tell, okay, if I can figure out what dependencies and what versions are in that project, then at least I can look in that offline index that's in the image and say, oh, this is the licenses associated with that version and that name. Now, there's going to be a lot of cases where I can't tell you because of like the private registry scenarios where you publish a package to a private registry with an internal software license that we don't know about ahead of time. But at least there's a good chunk of information that I can pre-compute in the offline index instead of having it to do at runtime. At runtime today, what we're doing is we're installing the packages. And then from the package manager tool, we ask it, can you tell me what packages are installed and what versions of those tools? And that's great because the package managers know how to parse the manifest file. They know how to like download the packages. They can, and as their schema changes, we don't have to deal with every schema change. The native package manager can do that across different major versions of the tooling. Where we fall apart is like we still have to make that outbound connection. So the starting point that I came up with was, may I share my screen? Is that okay? Yeah.
It is okay as soon as you don't mention anything confidential like a customer name or anything. I would like to remind everyone that this is a recorded session that we plan to publish on YouTube. So please refrain yourself from mentioning them, and I'm the first one to do that. So that's why I like to remember.
Just don't tell me any customer names, and then I'll never know, right? Just make it easy for me. I don't know who our customers are.
Just mention 3 letters, and for sure that's going to be a customer name.
GitHub's our customer, right? Can I say that? GitHub's our customer? That's not true. Stop it, Mo. Stop it. Okay, so the way I was looking at this problem was I was going to do a code walkthrough of License Finder, but maybe I'm going to rewind here. So I wanted to see, okay, here's my starting point. I'm going to just use this as sort of like my whiteboard for now. Okay, so assuming that I can determine I can parse a lock file, right? I mean, we've got gemfile.lock, we've got pipfile.lock, and we've got pom.xml. We've got some lock files that are difficult, like the Gradle ones. I don't know what to do there exactly, but we have lock files. And for the most part, we know how to parse lock files. And those lock files gives us a couple pieces of information. they give us a list of dependencies, their name and their version, right? And in order to get the name and the version, for the most part, that tells us what dependencies a project has. What it doesn't tell us is like, what is the software license associated with that license, with that version of that package name and version. And so to get that information, we ask the package manager, can you tell us? In the case of gemfile.lock, in the actual gem spec, there is a license attribute. And if it's defined in the actual license attribute, then we can get that directly from disk. If it's not, then we have to do an API lookup to rubygems.org. And there's like a JSON endpoint that will return some JSON representation of that, which I think is in most cases very similar to the spec file or the actual spec file. So in fact, we can even skip this step.
So Mo, it exists in the gem if the authors put it in the gem, but it would exist on Ruby gems if when they upload the gem, then they filled it out like manually. Is that why?
In that particular case, it is from the gem spec. There is an additional step. So the API would match the gem spec itself. But the thought that came to me is like, I'm having to determine this every single time that I install Rails, right? Once I've installed Rails once, Rails 5.0.0, and I've determined its license as MIT, can I take that information and store it so that I can reuse that knowledge for future scans, rather than having to recompute it every time, meaning and reinstalling Rails, parsing the Rails gem spec file, and figuring out that it's MIT. So the way I looked at it, it's like, okay, yeah, this knowledge exists. What if I were to build an offline index, right? So I had an index, which let's just represent as a CSV file. And in this case, it's just the package name, the version 5.0.0, and the software license associated with it. And if in that index, I could represent every single version of Rails, I don't know, 3.2.0, and the software license associated with that, because the software license can change depending on versions, then this pre-computed information, I can use at scan time. I don't have to go reparse the gem spec file because I've already done that once. And if I can represent this information in a small enough index format that first of all has to be optimized for humans, because there's going to be errors in that data. So humans need to be able to contribute. And then second, optimized for machines. So we can actually transport it so it's small enough and we can read into it and get the information that we need as quickly as possible. Then I save myself having to do the actual package install step, plus the parsing of the gem specs, plus determining the software license from those gem specs. And I can enhance. Like today, there's actually multiple sources of information for this license. It isn't just the gem spec, but we can also actually search the project files for a license file, and then from the license file, determine what the license is. So if I could actually take that parsing and that knowledge, instead of doing it at scan time, do it offline ahead of time in this index, I can actually improve the efficacy of that index. I can improve the scan time because I don't have to download packages. I don't have to parse those packages. I just take the data that I have, which in some cases is just the gem file lock, name, version, go look it up in the index. I'm like, okay, this is a crazy idea, Mo. Why would you want, like this has got to be billions of bytes of data, right? To store this much information. So I started with, my tracer bullet was spandex. So let's just take, if you go gem install spandex today, you will need Ruby. And this is my tracer bullet. It is not beautiful code, but it is free and it's open and up there. And one of the things I want to do is I want to be able to track all the network calls. So to do that, I have all network calls going through a single HTTP client, and that client allows me to log all traffic to a log file that I specify. So I'm just going to give you an example of what a lookup would look like when I'm allowing outbound network calls. So I'm going to scan, let's do the GitLab. GitLab or GitLab, what is it, the development kit, GitLab, gemfile.lock. So I'm just going to parse the gemfile.lock, and I'm also just going to redirect all the logs to a local disk here, and let's see what happens. Please don't blow up in my face, demo time.
Mo, can you just describe what spandex does?
So spandex is, at this point, it's going to go parse that log file. It is going to take each version of each, like it's going to determine each gem that's in that log file, take the name and version. It's going to check an offline index, which I haven't shown you yet, which is stored on disk, and see if I have a known license for that offline index. If it doesn't have a known license in the offline index, it then makes a call to the RubyGems API to look up the license for that gem at scan time. So it's going to pull what it can from like the local offline cache and then fall back to the network to actually determine the information it couldn't find locally. So if we look at the HTTP log, we can see this is every network request that went out to do this scan. In this case, most of the gems are MIT licenses. Why did I choose JSON? I don't know. That was the existing report format, and I thought I'll just play along. In hindsight, I probably would have done a line-by-line report, which is easier to parse, but that's again, this is just an experiment. This was not production ready, I don't think. But you can see here are the licenses that we were able to determine. So in many cases, it was MIT, some Apache, Thrift we weren't able to determine. So this is something that we'd have to go look at the project source code and see, is there a license file? Why didn't they specify it in the gem spec? What is it? And we can add that data to the offline index. The second piece is like, okay, here was all the network calls that were made. So if we look at the
did Thrift not have a license even on Ruby gems?
No, it did not. Okay. So this is like, if we look through the log here, we'd be able to see the API call for Thrift, and we weren't able to determine the software license for it. So that one is one that needs additional information. Now I'm going to do the same scan, but I'm just going to add a -a to the end, and this is going to be my air gap mode.
And so the Thrift would fail in today's implementation, right? It would just not have a license?
It would be empty, yeah.
Okay.
So if we take a look at the actual air gap file now, we'll see these are all the network requests that were made, cache misses. So these are all the ones that weren't in my local cache in terms of like the offline index. But you can also see that there were quite a few that were detected, MIT, Ruby, MIT, Apache. So I was actually able to provide some information for known licenses that I was able to compute offline. But there was also quite a few that I don't have because these require network access to determine that. So now if we were to take those two reports and we can actually do a diff, let's do a diff of air gap.json, and let's just see the level of difference between the air gap version versus the non-air gap version. And let me close this. We don't need that anymore. We don't need the -a, and then what I want is, let's just call this live.json. And now I'm going to do a diff. So you're going to see, like, I expect to see that the live.json is going to have a more comprehensive list of software licenses because it was able to make network calls in the places where I couldn't find the license in the offline index. But let's see what the difference is. And that difference is going to be as good as my offline index, as complete as that offline index can be. So now if we do vim diff, please tell me to stop talking if I just took too much of the air time here. Okay, so first one, Ace Rails AP. We can see on the right-hand side, we were able to determine MIT, left-hand side, nothing. Acme client, both hit, right? This was in the index, yay. Right-hand side, Apollo upload server. We have it on the, if we're able to make outbound calls, but we didn't in the air gap mode. But we did have a hit on Asana. We had a miss on a batch loader. We had a hit on Beacon. So you can see that like, it's not as complete as the live mode, but it has some level of completeness that we couldn't have achieved if I had to install packages in a scenario where I have true air gap, like you have no outbound connections. So this solution sort of works to some extent. In the live mode, it actually works better because it's going to pull the data that it has local first. If it doesn't have it, then it goes out to the internet to get the missing information. And I would love to be able to take that missing information and feed it back into the index by some route. I haven't figured out how. Okay, so let's look at this completely unoptimized index. Any questions so far?
Got a question, but a statement that this will be a constantly moving target because we are constantly releasing new versions on every software. So we constantly have to keep track of those new versions to add them to the offline index, which means we need to have a high frequency update of this offline index to provide relevant data to the customers.
Absolutely. So right now, my high frequency of offline index is 1 day. Now that high frequency, like you get a better value, meaning you get more cache hits, the more frequent you update that index. However, for any cache misses, you can still go get that missing information by making outbound network calls. So the level of accuracy in the report doesn't increase or decrease that much for live mode when you're not updating the index as often. Now, with this scenario where I'm using Postgres here, so what I found is like on Ruby Gems, they have nightly backups of the Ruby Gems database. And so what this does is on a cron, it pulls down the latest nightly backup. It attaches a Postgres connection to that backup, and it fetches out all the Ruby Gems from the Ruby Gems table and builds an offline index that looks like this. At the moment, it's just a bunch of CSV files. I partitioned it into 256 different files because I wanted to be able to sort of balance them as much as I could. I couldn't find a good partition key in this case because I don't know what, like if if we overuse the letter E as a prefix versus underusing the letter Z. So I just chose an arbitrary partition key, which is the name of the gem. I take the name of the gem, I SHA-256 of that, take the first two characters, and this gives me approximately 256 data files that I can put the data in. So this is it. This isn't optimized for human consumption, not for machines. And if we actually check to see how much space on disk does this take, so far it's not a complete index, so it's not going to be representative of all of Ruby Gems. So in this case, it's 5 megabytes, and the number of items in the index is not comprehensive. List. Oops, sorry. So we've got approximately 142,000. So because I'm only doing nightly diffs, and I've only been doing this for a few weeks, that's the number of records that I have in the database. But what I came to the realization is I don't actually need to index every single version of every single gem. And this actually works better because this is only indexing the latest versions of published gems, because the mission of our team is to keep you up to date, right? We want to give you like tools to say, this is why you should update to the latest version of this gem because these are the vulnerabilities associated with it. So if you're on version 0.1.0 of Hibernate, you've probably got so many vulnerabilities that, me telling you the software license, yeah, it's going to be more expensive because like not having that in the index is fine because in an ideal world, we don't have many people using older versions. So I don't know if this actually ever needs to be a complete index. Okay, Mo, that's great for Ruby, but what about Java? I don't know about Java, but I can tell you like parsing POM files, that pom.xml is another solved problem. And Maven Central does provide like an offline archive that you can download. When I last looked at it, it was something like 600 megabytes. And then when you expand it, it was like a couple of gigs. So being able to like unpack that and just take the software licenses you need and produce like a very focused, specialized index that can be optimized for deploying in a Docker image, I think is realistic, is actually doable. And CSV files we just saw was like 5 megabytes. If we actually take that and drop it even further, message pack, or even just ship a SQLite database, or even, I didn't even compress those files. And you saw how many times it said MIT in there. There's tons of duplication in those text files that a good compression algorithm would be able to highly compress those data directories. But I didn't focus on that for now. So what I did focus on is copying, copying from the Ruby advisory database, spandex, index update. So this is just going to pull the latest index via Git. So in essence, when you're building the Docker image, if this were a solution like an offline index, it's going to take a lot of work to actually build the index and keep it up to date, improve the efficacy of it, and then figure out what an optimized machine version is for the scanners are. If we did choose to build this offline index and try to manage it, it's a bit of work, right? So each package manager is going to be different. And maybe it's not going to be a comprehensive list. Maybe you don't do this for all package managers. Maybe you just do this for specific ones, like the top 2 or 3 that we care about. It would at least get you some licenses for those truly air gap scenario, but then it also improves as your scan time because you've got some of that information already pre-computed and allows you to fall back to making network calls for the missing information. That was the experiment, and that's it. Oh, and can I scan a? Yes, and I can scan a POM file. Let me find one. 3268. But this doesn't have an offline index. I didn't build one for Maven or anything else. I am doing one for NuGet at the moment. The NuGet index is...
Now, Mo, this also relies on us scanning, like you're saying, Ruby gems or certain repositories, right? So if people are linking to, you know, in Ruby or in Rails, you can just pull a random repository off GitHub or any Git repository.
Yeah. And that's better to do ahead of time, not at scan time. So so in the case of the NuGet one, I'm finding like the original pages, there's so many misses because they've changed their spec that I'm just recording it in a NuGet.unknown file. And so this file is like, these are all the ones that I need to go like figure out by pulling down the source code, doing an offline analysis of the license file. Once I figured that out once, put it into the index, I don't want to have to scan that license file to do a match based on whatever the current licenses we have in SPDX at every scan time. I just want to do that like once ahead of time. And that's, this is what I'm calling my dead letter queue of things to figure out later.
I think what Seth was mentioning is that you can refer to a dependency that is not especially a package in rubygems.org.
Oh.
It could be just a Git URL somewhere. Is that what you were referring to?
Yeah, so that's one. So yeah, I mean, I think the offline index idea is great. My question is, how many of our customers' packages is that going to cover? Like
it'll cover the public ones. The private ones, you'd have to give them an opportunity to insert those into the index themselves.
Yeah, and the truth of the matter is, I don't know how they're dealing with the private ones anyway, because presumably their application has to go out to the internet to get those.
Well, for private ones, it'd be hosted on their private, like Artifactory registries.
Right. And I guess that's the next piece is, would our license finder be written to go against their local repository?
I think that's the current goal. Correct me if I'm wrong. That is the current goal. The current goal is to see if we can use the existing license finder code. Let's go look at license finder. Okay, so here's an example of the Gradle package manager class in license finder. You can see it's using the download licenses task, which has to be installed as part of your Gradle build. And so the catch here is like where this command is happening, we have to convince it to get that information from a private source rather than whatever the public source is.
Right.
So I think this is the immediate direction, and honestly makes sense to me. Like if we can convince that to go to an internal source, then I don't have to maintain an offline index.
Do you know if that's written to have like multiple layers? So if the primary source fails, it goes to secondary, so on and so forth?
I'm not a Java person, but okay, let's look at the Gradle example I built here. So in Gradle, you can specify repositories in your build.gradle. And so there's some default ones like Maven Central, JCenter. And you can put more than one in here. So I've seen that in the documentation. So I think the next thing is just saying, okay, private, whatever that repo location is. And then hijacking or removing these for the private scenarios. So I believe so, Seth. Okay. I don't know for sure. That needs investigation. And it's also going to be dependent on each package manager's ability to. But so far, what I've seen, like Ruby, we already know, you just specify the source and you change that. The Gradle one here, it looks like you can specify the default ones, Maven Central, JCenter, and I haven't checked to see how to do the private ones. POM, let's go back to Maven.
So you will actually have to duplicate the same behaviors at the package manager when it comes to the logic about where to fetch the information.
This is
very interesting.
Yes and no, but yeah, like I'm parsing lock files, and so yeah, you're right. You're absolutely.
But the example from Seth is really pointing at this. Like, if you are setting multiple registry, for example, with fallbacks, this logic is included into the package manager, and we will have to replicate that one on our side in the license scanner in the way to find which registry to point at to find the license information.
Oh, I see what you're saying. Okay.
And this is joining my next comment on the doc, which is the alternate option is we already know that we will need to download the dependencies to build the project anyway, unless the project is built outside of GitLab, which I think is maybe a use case we might agree to not support for now. But if we need to build a project within GitLab, we need to download the dependencies. So we have those dependencies in the local file system. Have we looked at the different package manager and languages we're supporting today? And do we know if any of them doesn't contain the license metadata in the local file system and still requires to have the data being fetched on an external API?
Python.
I would like to extend that. If we're able to download and install the dependencies, that means we have access inside this air-gapped environment to a kind of registry.
Yeah, but
so even if we don't have that locally, that would be available directly on the network. So that's the only drawback that I see in this offline index. I think the idea is great. I just wonder if we will be in a position where we never have access to the data. And I understand that there's a performance hit by doing this this lookup on these registries, but
there can be one difference. You can have some replicate of public registry with some local features. Like, for example, the GitLab packages features, they could replicate the API to download the dependencies when it comes to building the project, but it might not replicate maybe a custom API that provides license informations. Yeah, and this is something that already pointed by Mo. And so, as you're saying, Mo, when you are installing Python dependencies, what you install locally doesn't include license information. You have to always reach out to the Python registry to get the license data, or at least maybe.
Yeah.
Okay.
Yeah, and I'm just going to, let's look at the code.
So I'm going to try and avoid to call out a customer name, but there's one Python customer we have who, one of their complaints they had with us frequently was that they pre-compiled everything before they put it on their GitLab instance. And so there could be situations where we're not using a on local area network registry because we're getting pre-compiled stuff. But in that case, like, are we going to just choke on it anyway? Because it doesn't have the expected little text files and things we need?
Well, we'd have to ship that as part of the artifact that we give them in their installation. So I don't completely know how we give them the Docker images today. I assume it's part of the omnibus. No? Oh, they're downloading.
I think they have to go fetch them. Yeah,
okay.
They go fetch them.
Well, if we could provide like the image as part of the omnibus, then that image would already have the offline index in it. I guess there's another assumption I just made and uncovered. I thought we were shipping as part of the omnibus.
That might be in the next iterations. I think Thomas already suggested that, but not part of the MVC.
I mean, on the other hand, if somebody is choosing not to use the scanners, if we keep by default having them all in the default package, our default package gets bigger and bloatier for things that people aren't using. So having some kind of option to say, I want all of the secure Docker images versus the base ones versus the whatever would make some customers happy, because then they could save how much they're downloading and scanning.
That's why I'm so excited about the comment on the package proxy and being able to host RPMs or deb files, because if we can host deb files specifically on gitlab.com, then as we ship it as part of like the omnibus, at install time, we don't have to bake everything into the image. We can actually just install the deb files with these indexes or the tools as part of the scan step without having to reach out, because my assumption there is like, yes, you're in air gap mode, but you still need to be able to touch your local self installation of GitLab, meaning you'd be able to access any packages that we ship as part of the GitLab.com.
I'm pretty sure we can write that one down as an assumption and be like, so my current assumption is within your local area network for limited access scanning or limited internet connection scanning, you have to be able to connect with your runners, your GitLab instance,
right?
So there's a bunch of what I believe to be very reasonable assumptions that we should list out so that somebody could tell us if they've got some other scenario. But I think that's perfectly reasonable to say, like, your runners, your, GitLab instance, your code, etc. Whether or not they're in that same spot, you need to be able to call them within your cluster.
So I can't tell me we have the ability to host deb files. I'd be so happy. And
if you don't, there is always this possibility of having a reserved namespace like /secure, where we have a project that the customers would be able to fork, and that would have scheduled pipelines downloading the files on a regular basis. I'm saying that because if you have that, you can assign some very specific runners that would be able to fetch something outside of the current.
I don't think we can rely on cloning or forking though, because sometimes these customers need to be able to do a download command on one machine and then drag those files and contents over to the GitLab limited connectivity instance and have them scanned before they hit there. So could they do that on just a regular computer, like request a fork?
If they're, because the project itself doesn't contain any package. The project would be just a way to download the packages. So actually all the hard lifting is done by the runner, not the project itself or the GitLab instance.
Yeah, so all I would have to do is run a command. It would give me the files. I could have those files scanned by security and then put
That's a pipeline, yes. A scheduled pipeline. And so they can define and they can choose wherever
I might not be able to have a pipeline reach out to the interwebs. I'm saying I have to be able to do this on like my computer in a DMZ area.
Well, you can install a runner locally on your computer in a DMZ.
Okay, yeah, but like I can do a single command on my computer, have it bring all those files down, and then copy paste those files into the instance.
That's the point is to download that and to upload that somewhere in the instance. We don't know where exactly. Sorry, Lucas, I think I got you.
Yeah, that's fine. That's the script that we were talking about that does essentially like a Docker save SCP Docker load into the environment. So that's what we've been talking about for the air gap thing. So that's we have an established process for doing that. We just need to figure out how to recommend something like that to customers.
But they probably already have something like that already in place, because they need at least one base image to do any build job, right? So they need to find a way to put that base image.
Right, but they may have all cooked up their own personal method. So us being able to say, here's our recommended method, at least could get everyone following one process instead of whatever homegrown separate processes, which is harder to support.
Yeah, we can, but I think it's the same thing. It's like, what is your company's way to install any dependencies? And we provide the dependencies, and it's regular Docker images. Whatever the way to install the other Docker images in their company, they can just do the same way for our Docker images. Philip, you just get the conversation with that comment. So
Mo can see he can see the chat. So if your demo is over, can you stop sharing your screen?
Yeah.
Thanks.
What am I looking at here? Oh, my bad.
No worries.
All right. So the offline index looks great, but it comes with huge maintenance costs and a lot of work to have full coverage for every languages. This is what I kind of wrap up. Okay, I can wrap up this.
Yes, and it may not be necessary now that we had that conversation about the intranet, and my assumption of air gap meant one thing versus now. I see some value, but it's more like an optimization if we have intranet access.
But then it could be a fallback for language, because we are trying to find one solution for all languages, and this might be the best approach. Maybe we could have dedicated solution for, for example, Python. If we have no local license metadata for Python, maybe we could bring an index for Python dependencies. So we could just do this resolve, this lookup on the local index when we are dealing with Python projects. But for all the others, we can rely on the private registry to be contacted by license finder, and that will be all fine.
Yep.
I think that's the main concern here. That I love this idea of having different indexes, but we are making a lot of assumptions on the network where we want to see that running.
Yeah.
So I think the next step really would be to gather all the customers' requirements and information so that we have a better overview of what is really available inside this kind of network, if we have a registry or if it's just a package server.
So these customers respond better when you make a proposal and they can respond whether you guessed correctly or incorrectly. For whatever reason, that just seems to go well. So I think if we wrote out, you know, we believe that it is probable, this is the configuration, we have access to a package registry, blah, blah, blah. Like if we wrote that out as a unit and I could have the TAMs and stuff share that with the customers, I believe we would get a higher percentage of feedback than if we just asked them about, hey, could you tell us if you use X, Y, or Z? I have no idea why. That just seems to get better results. So if we could make a little statement where y'all could tell me, like, this is our preferred way that we'd like to see them set up, and then I can make a statement saying we currently believe that, and then I could get that kicked out, and then we could get feedback saying yay, nay. And I could like finish it with, if that's not currently the way that you're set up, would you be willing to share, you know, are you using X, Y, Z or something else?
Could you reduce it down to, would you prefer your updates to come via DVD or curl?
Include examples.
It's like choosing between your Netflix subscription.
We all see what happened to the DVD model with Netflix, though. On the other hand, they were not Blockbuster, so.
What would be the form of these issues?
Sorry, I missed the end part of that question. What would be the?
That's a question for Nicole. Where do you want to see that, and what's the form of this?
So I think in the investigation issue we have for trying to figure out a solution, we might want to put a comment with that, as well as maybe make a call out to it up in the description and just say, hey, we've had internal discussions. We believe that it's reasonable, you know, based on talking to people, that the environments are set up like XYZ, and that updates could be gotten through A or B. You know, we'd love for you to let your TAMs know or let us know through whatever means if this is an incorrect assumption, because we're going to be prioritizing currently X and Y until you tell us otherwise, and then I can send that comment around to everybody. And then if we want to like draft, kick that around in like a Google Doc so we can all tweak it to make sure it's clear before it gets pasted in there, just to save shenanigans, we could always do that.
All right. Who's the DRI on this? I can do that unless Mo, you want to do so. I can do it.
I would love for you, Philippe.
All right.
I think I did a poor job of communicating via text previously. And so this is an opportunity to get better, but I also feel more comfortable with the
No, that's right, because we have no demo that is talking to everyone, and we can clearly see all the advantages and maybe the disadvantages of this POC, but that's great.
Okay,
I just have the same worry as on the maintenance.
I'm writing down some conclusions to make sure we agree on what has been said here, and have a quick summary of what we're aiming toward what we're going to do. Sorry. So Offline index has high maintenance costs, but might still be useful for language and package manager that can get the license metadata with local registries or downloaded dependencies. But the primary way to address airgap support will be to allow license finder to be configured to allow calling local registries instead of public ones. Do we agree with this?
Yes.
Okay. Any other things that we want to
The
talk
next thing we might want to say is we believe that getting the updates via curl on an internet accessible machine and copying those files to the air gap is an acceptable method of receiving updates. See, that's what I said. If we just say like, we believe this is acceptable, and then we like phrase it together and be like, after brainstorming XYZ, they will let us know if we are incorrect. We just need to say we believe X based on our discussions, and I'm sure we will hear otherwise if otherwise is the case.
But just to be sure, when you say these files and where Olivier is writing updates, we're talking about the offline indexes?
No, the images.
The Docker images for the scanners themselves.
Okay, so that's, for me, that's way beyond the scope of license compliance. But
I mean, that's right. That's what we're saying right now for SAST and everything is yeah. You got to be able to go get the Docker image somewhere and bring it in.
Yeah, I agree. Yeah, definitely.
Please and thank you.
This is where every issue is linking to other issues because we all come back to what is an air gap environment? How do you deal with it?
So I'm hoping that MR, I booped David this morning and Sam. I'm hoping that MR gets put public so we can just point to the user documentation because I have a public definition of that once that gets merged. And so I'm hoping it gets merged soon so we can all just point there constantly instead of reiterating like one single source of truth. What does it mean to us? And we can keep fixing that MR or making new MRs against it, but I want to have one single source of truth.
Could you put that in the doc somewhere or in the chat?
It's in the group conversation this morning in response to.
Okay.
Yeah.
I find it.
I can find it again if I need to.
No, I found it before.
Until we get some answers to these questions, is it okay if I assume intranet, like, so that I can I'm trying to figure out like what's the next step for myself in terms of license compliance?
Assume that there is for the primary language we're looking at, that there's going to be a registry that they're maintaining that you can get to, with the caveat it probably is going to have some CA username password nonsense going on. So I don't know if you want to make that like a second issue to follow up on, but that is highly probable that that's going to be the case.
So, okay. And primary language, again, is Java, right? Like Maven, would that be?
I made a comment in that issue. Is that what the comment in the issue said? Because that's the latest data I have. I can go find it if I need to.
Just a quick word on CA support. We just rolled out that for all the other security features. So there may be definitely some inspiration to find there.
Python's number 1, Java's number 2, JavaScript's number 3, C is number 4.
Python is number 1?
I'm sorry, that's
the one where we don't have.
Then we have a follow-up question.
If you want to solve for Java first, like that's in the top 2, that's okay. So solve for that one first, and then.
No, I think like I don't mind doing the hardest one first.
But that's
which Python? Because Python has multiple ways to play with dependencies, and it can have different outcome.
So if you can phrase that in a way I can ask.
Is it pipfile.lock? Is it requirements.txt? Is it another, less known package manager that they're using, or lock file format? I think that's
so. Which lock file and package manager?
Package manager,
yeah.
That's the question.
Yeah. If we need some,
I will go ask that. However, this customer has a lot of projects, and so the answer may be all of them.
Okay. I'm trying to break this problem down into something that I can demo like this week. That's what I want to.
If you want to start with Java, it is one of the top two. If Java is easier for you to wrap around and start with, and then what I will do is I will go ask that Python question now and attempt to get that answer as soon as possible.
I'm good. I would like to focus on Maven, I think. Yes, if I could demo a Maven. I need to get a private Artifactory or something. Do we have access to licenses for Artifactory, or is that available? And it's not through GitLab, is it? I'll figure this out. Stop. Okay, that's enough.
So I was saying, if Python is the priority and we need something up and running really quick, I remember that one of our customers replaced our license finder analyzer by this, which doesn't seem to require a network connection. I'm not 100% sure, but it's worth trying. And the good part is this tool has a format output that is compatible with license finder. So we would be able to get the results directly into the parsers. The only issue that we have is we don't have a way to tell license finder, the license finder analyzer don't start if there is a Python file yet. So both analyzers will try to run at the same time.
Before I hit comment, is this an accurate question? Would you be able to find out for me which types of lock file and which package managers specifically are in use for Python, and which Java package manager, Maven or JFrog or Artifactory, is in use?
For the Maven one, it'll be Maven or Gradle. JFrog, I think, is like endpoint. Artifactory would be like an example of a package.
That might be the tool they're using. Okay, so just saying Maven or Gradle will get us what we need.
Yeah, I think so for the Java scenario. And then for Python, could you just repeat the Python part again?
Which types of lock files with which package managers are in use for Python?
I just added to do in the doc for you, Nicole, with that question.
Perfect, thank you.
Thanks. And one last question. Is there a demo every Friday?
There is a demo every week.
Okay.
I haven't been invited to it yet, so I don't know when it is. It covers all of the scanners. So the first one, for example, could be SAST, and then the next one could be us, et cetera, et cetera. I need to verify things are not clear.
All right, as long as we're brainstorming, I'd like to upvote Philippe's comment regarding having a repo and then updating from the repo, like having the index in the repo, because I think GitLab, we offer this forking functionality where you can mirror a fork. So if we're okay with getting stuff from the internet intermittently, then if we give the client a fork of our index, then what can happen is we can create a CI pipeline on their side that they can intermittently pull the fork and then create MRs. And then that's a lot more visible, right? That's like, rather than merging Docker registries, which are like opaque, like we trust obviously GitLab, but they can just see the MR, right? And they can just review, like, here's the index and here's a few more licenses. And I think that might be a little more transparent for them. So just upvote on Philippe's idea.
Is there any chance we could do like a demo of what that looks like? The mirroring of the repo and then the pipeline. It sounds to hit the points that are concerning, but I haven't used it. Maybe I should just go read the manual.
Yeah, I could see if I can come up with something like a demo of this.
Yay.
All right, should we stop there?
Big agrees.
Perfect timing.
That's why he was asking. He was muted just before. And, all right. That was great. Thank you, everyone. So next step, I'm going to comment on the issue, and we will ask the customers if it's a good fit or not. I will probably start with the Google Docs as you advised, Nico, so that we can share before commenting. All right. Thanks, everyone. Have a good rest of your day. Good luck with the kids.